Hello. In this lesson, we learn how to add a layer of cloth simulation on our crowds. First, we'll be preparing our agents to be ready to be used with Vellum and perform a cloth simulation on top of an existing crowd setup. So let's get started. Before we can actually proceed with the cloth simulation, we need to decide what parts of the character need to be simulated. So for that, we'll go back to our agent template. I'll head back to my first agent. Let's take an attribute triangle. For our peasant girl, I'll call this for Vellum. We can select the primitives for our skirt. To select a loop, you can hold A and click your middle mouse button, and shift select to select more loops. If you want to only select the primitives that are in the front and no backside points, you can click on the select visible geometry only toggle. And this way, it will only select the front faces and won't affect the points that are behind it. Once you're happy with your selection, you can press enter. And in the wrangle, let's type s at fpx underscore material underscore name is equal to for Vellum. Make sure to set the run over to primitives. So now we need to create a group. I'll call this pin. And I'll select the parts of our geometry that I want my cloth to be attached to. So once you're happy with the selection, you can press enter and redo the agent definition cache. Now, I have downloaded one more character from Mixamo to demonstrate how different parts of clothing can be simulated. We'll be simulating the cloak of our character. So I'll bring in my character. Once you have your character, if you want, you can visualize your characters using the materials. Or we can keep it separated to make our simulation geometry less heavy. I will be taking an attribute triangle and select my cloak. I will also select the headgear. Now I want to create this as a separate shape in my simulation. So for that, I'll change the FPX material name to for Vellum. I can now create a new group. Let's make the type to be primitives, where I select the parts of the cloak that I want to follow the animation without being simulated. I'll once again call this group pin. If we go in our shapes, we can see that we have a second shape coming in called for Vellum. This way, we can manipulate the Vellum geometry without ever affecting our base geometry. So let's do an agent definition cache for this agent as well. And for the animation, I've downloaded a walking animation. So once you have it all set up, we can take a new geonode, call it Vellum on Crowds. We'll take an object merge and bring in both our agents. I'll take a crowdsource node. Instead of scattering on the default geometry this time, I'll scatter this on a grid. Let's move this slightly off center. Set the number of agents to 10 in our crowdsource node. Now, since we have multiple agents, we can go to the Randomize tab and click on Randomize Agent Primitive. I'll select both my agents and once you're happy with the distribution, we can take a crowd motion path node, connect it to our crowdsource node. In the clip assignment, set the clips to walking. We'll take a crowd motion path follow and create a basic curve to drive our crowds. Let's take a resample and set the treat polygons as to subdivision curves and connect it to a crowd motion path follow. Again, increase the distance variation and smoothing. Let's also add a crowd motion path avoid. Set the max turn rate to 30 and the particle scale to 1. I'll turn off the LOD agent reduction in the viewport. Since we don't have that many agents to work with, let's take a crowd motion path evaluate node. And that is the output for our crowd setup. Now to actually do the cloth simulation on the agents, we first need to unpack our agents. So we'll take an agent Vellum unpack node. In the geometry tab, I will select the shape for Vellum. Now since these Mixamo geometries are quite low res, I'll increase their subdivisions before we are able to simulate it. So let's take a subdivide, connect it to my Vellum geometry and increase the depth to 2. So we see we are getting quite a lot of geometry to work with. For any cloth simulation, we don't want our cloth to be simulated from the first frame. Rather, we need a pre-roll between our Vellum start frame versus our crowd start frame. We can get that by setting our Vellum start frame to -25 and deleting channels for the crowd start frame and set it to 1. Now, in our collision geometry, I'll take a time shift. I will copy the Vellum start frame parameter and paste relative references. So you can see we are getting our geometry on T-pose. Since we always want to start a Vellum simulation using a T-pose. After that, I can take a blend shapes node, input the blend source 1 as the time shift and the collision geometry as my second blend source. Now I go to frame -25 and put a key in blend 1. Now let's come to frame 1 and switch my blend 1 to 1 and put another key. So before we start our animation, we get a nice pre-roll where we give 25 frames for our cloth to settle in the correct positions. We can see that we have some open geometries in our collision geometries, which Vellum simulation does not like having as a collision. So let's take a polycap node to close out these geometries. I'll take a Vellum configure cloth and connect my Vellum geometry in the first input and my collision geometry in my third input. You can play around with these values to get the correct settings based on the cloth requirements of your scene. But for now, I'll just change my stiffness to 10,000 since that is the value I found to be working best. Next, we can take a Vellum attached to geometry node and connect it to our Vellum cloth. I'll set the group to pin. Then I'll take my Vellum solver I'll set this to manual mode for now and set my start frame to 1. Now, before we simulate this, in our Vellum solver, I'll copy the parameter of our Vellum start frame and paste relative references in the start frame parameter. I'll take a Vellum post process, set the spatial blur to 1, enable detangle and extrude by thickness. For now, I'll disable the Vellum solver. We'll come to simulating it a bit later. Next, for our materials to work in Solaris for our cloth, I need to set its path correctly. For that, I need to create an attribute. I'll take an attribute wrangle and set it to primitives. I'll take a new attribute called s@agent_path, which will be my agent name plus my agent shape name. So we can take a point attribute, add it with a slash, and then we can use our agent shape name to set our agent path. This will be helpful to set the path in Solaris. For our agent name attribute to come through, we need to set it in the agent Vellum unpack. Transfer attributes to agent name. Now we have our agent path correctly set up. We can take a null and call it out_cfx. Let's go to stage. I'll take a SOP crowd import and copy my out crowd null and paste it in the SOP crowd import. Now, before we can replace our cloth geometry with our Vellum simulated geometry, I need to prune my shape asterisk for Vellum. So now we have our agents coming in without the cloth geometry. I'll set this to manual mode for a bit. I'll take a SOP import node this time, copy my out CFX and paste it here. Next, let's take a USD ROP node. I will call this Vellum on crowds. Select render specific frame range. I'll set the render frame range till 120 for now. In the import path prefix, I'll put it as Vellum on crowds again. For both our crowds as well as our cloth, so that they live in the same hierarchy. Before viewing our simulation, let's just cache it out once to make sure our materials are working. So let's go back to the object level and enable the Vellum solver. Make sure in our USD ROP, initialize simulation operations is on. Since we have a pre-roll, Houdini doesn't always initialize the simulation and might have some old information baked in. It's always good to have this on if you have a simulation that you need to be cached. So let's click on Save to Disk. Once your USD is cached out, we can take a sublayer node, go to the location where it's cached out, and re-import it. Now, if we view this, we can see that our crowd is coming in with a cloth simulation. There's still some issues which we'll fix once we have tested with the materials applied to our cloth. I'll be using the same script that we have previously created and duplicated. The only difference between the two scripts will be the primitive selection as well as how the agent path will be set up. So if we go in Vellum on crowds, go inside CFX, we see that we have our shapes coming in. But these don't match the agent definition shapes. So to fix that, in our SOP import, we can go to primitive definition and in path attributes, set this to agent path, which is the attribute we had previously created. Now, let's connect temporarily both our angles to our SOP import. I'll rename this to apply cloth mat. And instead of the agent definitions, I'll select my CFX, which is our cloth hierarchy. In the agent path expression, instead of taking the parent path of the parent, I'll let it take the parent path directly of the prim. And that should be all you need to apply your materials. Now, we can take a scene import materials and connect it to our SOP crowd import. Before we can see the materials on our cloth, we need to recreate our materials so that our for vellum shape comes as a separate material. Let's do that for both our agents. And now, if we head back to stage and switch to Karma XPU, the material grouping seems to be incorrect. Let's head back to SOPs and check our agent path wrangle. We need to set this to ptnum instead of primnum. Let's head back to stage once again. And we have our materials working. Before we can do the final simulation, I would like to add a ground for our cloth to interact with. So let's take a grid. I'll view my characters, and based on my character's first position and last position, I'll set the ground size. I'll go to frame minus 25 again, set this to minus 2 in Y, and come back to frame 1 and set it to 0. We can merge it with our crowds and check if our feet are correctly placed on the ground. The reason we animate this value is to make sure that we don't have any penetrations with the ground. Now, we can merge this with our collision geometry. Let's set it to manual mode once again and enable the Vellum solver. Go back to stage, set the start frame to 1 and enable all the inputs once again. We can connect our two angles to the sublayer node. And press save to disk. Alright, so our cloth is now simulated for both our characters. We can now take another SOP import and import our ground and add a color node to just give it a color for visualization. I'll also add a light. So that's it for this lesson. In the next lesson, we'll be talking more in depth about Solaris and the essential Solaris knowledge required to render out your crowds. Thanks for watching and see you in the next lesson.